At this point, we have been introduced to an imaginary number, and if you recall from a previous lesson, we could say that the imaginary unit is equal to the square root of -1. So we're going to take that concept and we're going to kind of build upon it. Now, one of the first things that you need to be aware of is that whenever you take the imaginary unit and you square it, so if I were to square both sides of this, I would get the square root of -1 squared, and then simply the square root and the power are going to cancel each other out, leaving you -1. So this is a very important concept that you understand, that I squared also equals -1. Now, when we take the imaginary unit and we combine it together with a real number, if the real number is acting like a coefficient, this is still an imaginary number. However, if we are taking the real number and adding it to the imaginary unit, what we have here is a situation where we do not have like terms. And so since we don't have like terms, we have one real part and we have one imaginary part. And this is what we call a complex number. Complex numbers are always written with the real part first and the imaginary part second. And we represent that with simply standard form being an a plus a bi. Keep in mind that this can also be a minus bi. The plus is just representing addition or subtraction. But the real part first, the imaginary part second, is a standard form to write a complex number. So this is important, that whenever you are simplifying a complex number or you're solving a quadratic that has an imaginary part, that you put it in standard form for complex numbers. So keep that in mind. Now, we have a little Venn diagram here showing you how real numbers and imaginary numbers relate to each other, and how complex numbers fit into the whole system. So if we go down, we can take a look at how this works. Now, if we're asking you to simplify complex numbers and imaginary numbers, we're basically asking you to combine like terms. And so we have a number of ways in which we combine terms. We can do that through addition, subtraction, multiplication, or division. And of course, each one of these has a different look to it. Now, the one thing that I want you to keep in mind here is, even though the imaginary number, imaginary unit has an actual value, it acts just like any other variable, like an x or a y, whenever we're talking about combining like terms. So if you look at this, if we have two imaginary numbers or two real parts, so we basically have two complex numbers being added together, we could simply recombine the real parts together and then combine the imaginary parts together and come up with a new complex number. Whenever you add the complex numbers, whenever you add the imaginary parts, you're just combining the like terms. Now, if we're subtracting, we have to keep in mind that we have to distribute this negative to both parts whenever we do this, so that we are getting the appropriate value before we regroup them or we combine like terms. And so that's something that you'll want to keep an eye out for, is subtraction. Now, you need to be very aware. If I had a problem like 2 plus I minus 3 plus 2I, that problem is very different than 2 plus I times 3 plus 2I. You don't want to get these confused. It's very important that you recognize that negative, and that negative gets distributed to both parts before you drop the parentheses and start combining like terms. And so just keep an eye out for when you're given parentheses that you don't have an operation between those two. So let's take a look at a couple samples here. So we have sample problem number 2. And on sample problem number 2, what happens here is that we give you a couple different looks. We give you one where we're adding. Now, if you really want to think about this, you could simply drop the parentheses and have 4 minus I plus 3 plus 2I. And then if you are comfortable just finding the like terms, without having to actually regroup them. If you're comfortable doing that, you're more than free to do so. We just give you another method by regrouping to make it a little more straightforward. Now, if you look at part B, you can see there is a negative, so that has to be distributed before you can actually drop those parentheses. And of course, part C really is, we're making more of it than is need to be here. In this case, you just need to drop the you need to distribute the negative, and then you can drop all the parentheses and combine the like terms. If the regrouping is confusing for you, that's fine. You don't have to use that particular instance. So go ahead and take sample problem number 2 and work part A, B, and C. And keep in mind, you're doing the same thing you would do if that variable were an x. So just go ahead and combine like terms and simplify these expressions. And it says to write the complex number in standard form. So remember, that's A plus BI format for your final answer. Okay, so we can see here we have a plus between the parentheses. So whenever I see plus, I don't even really feel like I need the parentheses. I can do that and just drop the parentheses. Now, you have a choice here. If you want to rewrite in an order that groups them, you're more than welcome to do that. If you feel like you're comfortable doing it in your head, you can do that as well. -1 plus 3 is a 2. 2i plus 3i is a positive 5i. And you can see that that's written in complex standard form. Alright, now a difference here in part B is we have a negative, so before I can drop these parentheses, I've got to distribute that negative to both parts of that parenthesis. Then I can regroup if you feel it's necessary for you. And then I can simply combine like terms. And again, complex number standard form. Lastly, we're going to have both operations taking place here. So I'm going to distribute the negative to both parts. And then this one I'm just going to kind of take in my head. So I'm going to say that's -3 and a positive 2, which is going to give me a -1. And then I have 2i minus I minus 3i. So it's going to give me -2i. And then I am done with that problem. So this has been a quick introduction to complex numbers and simplifying complex numbers through addition and subtraction. In the next video, we'll go into multiplication.